which shows option C is correct. If minus 1 to 3 by 2 integral of modulus of x sine pi x dx is equal to pi plus 1 upon a, where a is equal to option A, pi square, option B, 2 pi square, option C, 4 pi square, and option D is none of these. Now the range we select are minus 1 to 0, 0 to 1, and 1 to 3 by 2. X is negative from minus 1 to 0, positive from 0 to 1, and 1 to 3 by 2. But sine of pi x is negative from minus 1 to 0, and again positive from 0 to 1, and negative from 1 to 3 by 2. Therefore, x sine pi x is positive from minus 1 to 0, positive again from 0 to 1, but negative from 1 to 3 by 2. So from the above table we observe that x sine pi x is positive when x goes from minus 1 to 1, and negative from 1 onwards to 3 by 2. Therefore, modulus of x sine pi x is equal to x sine pi x when x lies between minus 1 and 1, that is minus 1 is less than or equal to x less than or equal to 1, and minus x sine pi x when x goes from 1 to 3 by 2, that is 1 is less than or equal to x less than 3 by 2. Therefore, I is equal to, that is minus 1 to 3 by 2, modulus of x sine pi x dx is equal to minus 1 to 1, modulus of x sine pi x dx plus 1 to 3 by 2, modulus of x sine pi x dx. For the first integral, it becomes clearly x sine pi x. So it becomes minus 1 to 1, x sine pi x dx, plus for the second integral, it becomes minus x sine pi x. Therefore, 1 to 3 by 2 minus x sine pi x dx. But integral of x sine pi x dx is equal to, integrate by parts, x keeping as the first function, sine pi x as the second function, becomes x minus cos pi x upon pi minus times minus cos pi x upon pi, integral of this with respect to x, which in turn becomes minus x cos pi x upon pi plus sine pi x upon pi square. Thus I becomes minus x cos pi x upon pi plus sine pi x upon pi square from minus 1 to 1 minus x sine pi x upon pi plus sine pi x upon pi square from 1 to 3 by 2. Therefore it becomes minus 1 upon pi into cos pi minus 1 upon pi into cos of minus pi minus 3 by 2 pi into cos of 3 pi by 2 plus 1 upon pi square sine 3 pi by 2. That is when we put x equal to 3 by 2 minus times minus 1 upon pi cos pi. That is when we put x equal to 1. Therefore it becomes 1 upon pi minus 1 upon pi minus times 1 upon pi square times minus 1 minus pi, which simplifies to 1 upon pi square plus 1 upon pi, which is equal to 1 plus pi upon pi square, or pi plus 1 upon a as is given. Clearly a is equal to pi square, hence option A is correct. The next question is 0 to 1.5 integral of greatest integral value of x square dx, where this symbol is the greatest integer function, is equal to option A 2 plus root 2, option B 1 plus root 2, option C root 2 minus 1, and option D is 2 minus root 2. Now when we split x from 0 to 1.5 as 0 to 1, 1 to root 2 and root 2 to root 3. X square becomes, as 0 to 1, x square will be between 0 and 1. As x goes from 1 to root 2, x square will go from 1 less than or equal to x less than or equal to 2. When x goes from root 2 to root 3, x square becomes 2 is less than or equal to x less than 3. Greatest integral value of x square therefore becomes 0 in the first interval, that is between 0 to 1 as x, and 1 when x goes between 1 and root 2, and 2 when x goes between root 2 and root 3. Clearly, we can split now the integral I equal to 0 to 1.5, greatest integral value of x square dx is equal to 0 to 1, greatest value of x square, greatest integral value of x square dx, plus 1 to root 2, greatest integral value of x square dx, plus root 2 to 1.5, because root 2 is 1.414. Therefore, 1 root 2 to 1.5, greatest integral value of x square dx. Clearly, for the first part its value is 0, for the second part its value is 1, for the third part its value is 2. Hence, the given integral becomes 0 to 1, 0 dx, 1 to root 2, 1 dx, and root 2 to 1.5, 2 dx. 1 dx integral is x, 2 integral dx is 2x, therefore it becomes 0 in the first, root 2 minus 1 in the second, and 2 times 1.5 minus root 2 times in the third. That is root 2 minus 1 plus 3 minus 2 root 2, which is equal to 2 minus root 2. Clearly, the option D is correct.